Welcome to the presentation on soft computing in computer science. For the past few lectures, what we have seen is introduction to soft computing and analogies of soft computing and soft computing tools that are meant for doing a task called pattern recognition, particularly artificial neural network. Starting from the introduction to very basic ANN models to very widely used backpropagation neural network model we have seen, and their associated design challenges also we have discussed. So, soft computing can be studied with some practical exposure, then only you can get an idea about what these algorithms are all about and how these algorithms can be carried forward to do certain task in order to find a solution to a problem. So, in view of this presentation, what is planned is to give you a exposure on MATLAB software. As the title says, this MATLAB is a scientific computing tool which allows you to do certain kind of scientific computation. Let us see the presentation. In this presentation, what we are going to cover is, we are going to cover the development environment of the MATLAB software, basic MATLAB commands, how matrix are created and manipulated, how simple MATLAB programs can be written, how a function subroutine has been written in MATLAB environment, how to plot graphs in MATLAB environment, next to that the various advanced features available in MATLAB software, that is MATLAB toolboxes, otherwise called as apps in the MATLAB environment. Finally, this presentation is concluded with little glimpse about the Simulink environment of the MATLAB. Let us go one by one. See, the MATLAB has been derived from the name matrix laboratory. So, from the word matrix, 3 letter MAT has been taken, and from the word laboratory LAB has been taken. Put together it is called as matrix laboratory. If you could see that this software is an advanced interactive software package specifically designed for scientific and engineering computation. So, whatever may be the real world problems that dealt with pattern recognition, decision making, optimization in any of the scientific and engineering domain, this software is very much suited to solve or to find solution to that problem. Because this MATLAB environment, as it is shown in the diagram, has a programming interface, has facility to write user written function, and have lot of inbuilt functions. Those inbuilt functions are very powerful to solve graphics related operations, some mathematical computations like linear algebra, signal processing and all, and it has some external interface to connect this MATLAB environment with the C, C++, Java and other softwares. And of course, the power of MATLAB lies in the set of toolboxes. In recent days, these toolboxes are called by the name apps. One who are interested to do experiment with the signal processing, they can use signal processing toolbox. With respect to optimization, they can go for optimization toolbox. If they are interested in do some communication, they can. So likewise, there are plenty of apps, or what can I say, toolboxes are available, and you can use those toolboxes in order to find solution to your problem. As I said earlier, the MATLAB software has the name laboratory. So when you go to any laboratory, say for example when you go to a physics laboratory, so what you can find? You can find lot of physical apparatus using which you are about to do experiments. Likewise, when you go to chemistry laboratory, you will be provided with a lot of chemicals and chemical apparatus using which you can do some experiments, find the readings and report the readings, and you have to close the experiment. But this software, rather than the given name as simply a software, it is given as a name laboratory. It means it is a laboratory containing matrix as the fundamental element. So using that matrix, you are going to do wonders. So how we are going to do wonder? Let us see one by one. First, you should know about the MATLAB environment. So this is the screen where you can call by the name IDE. integrated development environment. Of course, this might be some older version of MATLAB software. Almost in many of the latest software you may have this kind of screen that are available, and you might know all what is the purpose of each and every window. If you could see that there is a window called workspace window, or otherwise called as sometimes there is a sub tab and see, say for example here this workspace window is there, and here the current directory window is there. In the current directory window you will see all the files that are stored in that particular working directory. You can see the current working directory here, you can see that. And in the workspace window, this tabbed pan, if you open that, you can find the relevant variables that are created particular to that what is the project or what is the program that you are writing currently. So all these are available. You can find the list of matrices, list of everything. So this thing will be very clear when it present you the practical sessions, right? And another important thing is command history window. So in the command history window you can see various list of commands that you have executed right from the MATLAB initial session to every day's session. It has been listed. See, date is there, time is there, what are the commands has been executed. So like that it has listed various commands. And another important window is the command window. This command window is the interaction window through which you interact the MATLAB software, and other way you can say that you can see the output in that window. So whatever the programs you are writing, the command related outputs, that is a text based outputs, can be seen in the command window. Otherwise you can see other kinds of windows like graphics or any other kind of outputs can be seen with the help of these other kind of windows that are present in the MATLAB environment. Like you can create a new file, you can open a new file, and other operations can be dealt with the kind of menus as well as toolbars available, and you can see this complete environment as a very user friendly environment in order to do most of the scientific as well as engineering computation. Next, the important concept is what is the fundamental variable that are used in MATLAB software. So as I said earlier, the MATLAB is nothing but matrix laboratory. So the fundamental variable is a matrix. So one has to understand the various aspects of a matrix. What is a matrix? It is a two-dimensional variable containing rows as well as columns. If you could see, the rows are in the horizontal direction and in the columns are in the vertical direction, and each element of a matrix is accessed by designating its name followed by the row value as well as the column value. So here in this Aij, A is the matrix name, I is the row name, and row number, J is the column number. Say for example, if I want to access this element, right, what is the row number? The row number is 3, that is I equal to 3. What is the column number? Column number J equal to 4. So how can I access that element value that is present in that location? A of 3, 4. So like that. So if you could see that in other language we can write this as it has been in a program, it can be written like this, A of 3, 4, like that, using square bracket. So if you want to use only this alone, then it is going to be, that is only column alone, that is called column vector, and it is called row vector containing only rows, row vector, like that. So what is vector? So in general, vector is a one-dimensional array, and what is matrix? Matrix with more than one dimension is going to be called the matrix variable. So as I said earlier, array is the fundamental unit of matrix. So this array has been converted to a matrix if it is has a multiple dimension, right? How to create a matrix as the vector? This is what this presentation is all about. So in order to create a matrix, you should first know the syntax, how to create. So in the command prompt, you should give the matrix name, say for example A, right? So then you have to put the equal symbol. So here you have to give the matrix name A, then followed by equal symbol, then you should put a square bracket, and in the square bracket you have to write the first row element, say for example 1, 2, 3, right. Then you have to put semicolon, then you have to write the second row element 4, 5, 6, then you have to put semicolon, then you have to write second row element 7, 8, 9, accordingly you should go. So if you type this command in the command prompt, what you have created is, you have created a matrix of size 3 cross 3 because 3 rows are there and 3 columns are there. You please note it down these commands because it is very useful when you go for practical session. So first you have to give the first row element, and in the first row element you have to give the column element 1, column element 2, column element 3, etc. up to column element, right. So first column element 1, second column element 2, third column element 3. So until this the first row is over. So the end of the row is designated by a semicolon. Likewise you should give the other row elements, and the square bracket denotes the end of the matrix. So here in this example a 5 cross 4 matrix is created. So this is the example where how a 5 cross 4 matrix is created. Say for example if you want to create one row that contains 4 elements, that is I want to create one row that contains 4 elements. How I can create? First I should give a name for that matrix, then I should open a square bracket. Since I have one row I can give like 10, 11, 12, 13, one row 4 elements. So then if you type this command you will get this command. So here one thing you have to remember, after typing this command if you put semicolon you won't get output, that is the output is not displayed in the command prompt. If you remove the semicolon and press enter then you will get the output. Likewise how to create a 4 cross 1 4 column. So how to execute these commands and all, you should go to the command prompt and type this command. So the one which is given in the dotted bullet. So these are all the commands. So these commands are used to create matrix and vector. The first one creates a matrix and the second one creates a row vector and this third one creates a column vector. So where you have to type? You have to type all these in the MATLAB environment, that is said that this is in the command prompt. Here you have to type. See here there is a double arrow is there, right. In the double arrow you have to write a equal to in a square bracket 1, 2, 3 semicolon, then 4, 5, 6. You put the square bracket. What is the output after pressing enter? What is the output you got? A is equal to in a square bracket 1, 2, 3, 4, 5, 6. Likewise you got. So this is the way in which you can visualize the output of the commands that you have given in the command prompt. And next is the manipulation. This is the most important topic that you should remember. So here I have created a matrix, say for example A equal to I can do a 4 cross 4 matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me close this. So what is the size of the matrix? The size of the matrix is number of rows. How many rows? 3 rows. Number of columns is 4 columns, right. So it is the size of matrix is 3 rows and 4 columns matrix, right. So from this matrix how can I create a variable? That is accessing a single element from a matrix. How to access a single element? As I said in the initial presentation, any element in the matrix can be represented by means of its row and column value. Say for example we want to access the element 3. Where is the element 3 is located? It is located in the first row as well as it is located in the third column. So how to access this? A of 1, 3. If you put that then it will give answer 3. See here, right. So in that case the element 3 is viewed as a singular, right. How to access a single element. Likewise how to access a single row from a matrix? So for which the syntax is you need to give a name. Say for example B equal to. What is the matrix name given? A. From A what I need to get? Row number. See row number. What is the starting row number? So I need to get from first row, comma. What is the starting column number? I need to get the column number 3. Between the starting column number and the ending column number you should put colon. So if you do so you will get the portion of the matrix from the existing matrix. So that means a portion of the row from the what row it is getting collected? First row, third row. So in this case if I want to collect this thing 5, 6, 7, 8. So how my syntax command should be, this is C equal to A of, what is I have to give? I have to give the row number 2, I have to give the column number. So first column to fourth columns. If you do so, my answer will be C equal to 5, 6, 7, 8. So this is the way you can get the output in order to. So these two are the first two steps in order to do the matrix multiplication. First one is accessing a single element from the matrix, and the second one is accessing a single row from a matrix. Like this, what we can do how to access a portion of the column, how to access a column from the matrix. Say for example, my matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is my matrix? What is my matrix size? A equal to A size is 2 rows and how many columns? 5 columns, right? 2 rows and 5 columns. So what I have to do? I am going to take the second row alone. That means column. I want to take a particular column, right? So second column alone. So what is the second column element? 2, 7. So in that case, what I have to do? D equal to A of, see the syntax, column vector name. So column vector name D equal to the matrix name you have to give. Then you have to give the starting row number. What is the starting row number for these two? It is available in 1, colon. What is the ending row number? Second row, right? Column number, second column. So you have to give the starting row number and the ending row number. In between the starting row number and the ending row number, don't forget to put the colon symbol, that is double dot, colon symbol, followed by the column number. It means it takes the all row values pertaining to the second column, since the column number you mentioned is the second. So that is the idea here. Likewise, you can also choose a particular element, single element, by mentioning the index value as a row, as a column value. So this is the accessing a single column from the matrix. Now how to access a matrix from a matrix? So for which, let us assume a matrix A equal to, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4, 3, 2, 1, 0. Let us finish this. So what is the size of this matrix? A equal to, what is the size? 1, 2, 3. That means 3 rows. How many columns are there? 1, 2, 3, 4, 5 columns are there. So there are 3 rows and 5 columns are there. Out of which I am going to choose this particular element. That is, my result matrix should be B equal to 7, 8, 3, 2. So what is the size of this B matrix? 2 rows, 2 columns, right? 2 rows, 2 columns. So how to access this? This is what the presentation is all about. I want to create a new matrix from the already existing matrix. Imagine that the existing matrix is a very big matrix, and from that big matrix I want to access a small portion of the matrix. If I want to access the small portion, so how do I do? I need to know the starting row number, colon ending row number, comma, starting column number and ending column number. So how to access this? B is equal to A of, what is the starting row number? This is the second row number, right? 2:3, right? What is the column number? This is second column, this is column, again 2:3. So in the row side also you have 2:3, in the column side also you have to 2:3, and the resultant answer for this is this one. So this is the idea you need to how for accessing a sub matrix, that is creating a matrix from a existing matrix. You may wonder how do this kind of a matrix manipulation is required. Say for example, you are doing a face recognition application. I already told that, right? Neural networks are meant for pattern recognition problem. One of the very popular pattern recognition problem is face recognition system. So imagine a face where eyes and nose and ears are there. I want to crop only this eye portion alone from this matrix. So what you do? You should give the entire image as an input to the MATLAB environment. If you do so, it will be a matrix of very large size, from which I need to take only the portion of this matrix which gives the image of right eye alone. So that means I need to access a portion of the matrix from the very big matrix. So this is what the n-side application, why we need to access a matrix from a whole matrix. So likewise there are so many commands. Say for example this command, if you take that, I want to take a matrix from which I want all the second row elements. This column signifies all. So you should remember the meaning of colon in the MATLAB. In one point, in one way it is mentioned as 2, that is a starting column number to ending column number, or starting row number to ending row number. If I put this colon individually, then it means signifies all. So that means n equal to a of 2 comma all. That means from the A matrix you have to take the second row and all column elements. Likewise, let you take the O. A is the given matrix from which you have to form O. In that you should take all the column row elements and only the fourth column elements. Likewise, here also you can mention. So now you should know the meaning. Now you compare this command A of colon comma colon. So all comma all, that means all rows and all columns from A matrix should be copied to Q matrix. This is what this command all about. So in this indirectly you can say that Q equal to A. This also hold good. That is A matrix is directly assigned to Q matrix. You can give this way also, or you can give all the elements also. In case the number of elements available, you can say 1 is to 2, that means first 2 elements, 3 is to 4, that is third and fourth column, like that also you can give. And another important command is, let me erase this. Another important command is size. If you take the size, it will give you the size of the matrix. Say for example my matrix is A equal to 1, 2, 2, 3, 4, like that. If you type size of A, then what it will do? It will give us 2 cross 2. That is the matrix size is 2 rows 2 columns. Likewise, if I want only the column size, then you have to do 2, A comma 2, size of A comma 2. If I give size of A comma 2, this 2 signifies I want only the column size. If you put 1, I want only the row size. And this is nothing but the A is calculated, size of A is calculated, and the row value is copied to R1 and the column value is copied to R2. So this is the another command. And what is this command? T equal to A dash, that is from the A matrix, its transpose is calculated, and the transpose of the matrix A is that. What is meant by transpose? Row value is converted into column and the column value is converted into rows. So that is the idea of this command. So let me go to the next command, zeros. If I want to create a matrix of size 2 comma 4 and all the values of this matrix are filled with only zeros, say for example I have to create only zeros. So like this, if I want to create only zeros, then you can use the command zeros. What if I want only ones in all the places? If I want to create only ones, then you need to use this command, ones of 2 comma 4. So this is what you need to do. And these are all some widely used and common matrix related commands. So that will be very useful for matrix manipulation. Next, now you are in a position to write simple MATLAB programs. How to write a MATLAB program? In the MATLAB window you see the file option, right? File menu, as well as creating a new file, right? You click that and your new environment is created, and in that environment you type this program. So what is this first command is all about, and it is my general practice to use these 2 commands. If I see all the programs, you can see these 2 commands in general in all the programs. I have taken only one example, that is how to check the eligibility of a person to vote, but in different version 1, version 2, version 3, version 4, and some more versions are there in the subsequent slides. What is there in the version 1? In the version 1, just I am going to assign the age of a person to a variable, and with the help of a simple if condition I am going to check whether that person age is eligible to vote or not. So for which the general practice is CLC and a clear all, I am using that. So what is CLC is? It is nothing but clear the command window. So in the command window, whatever the command that you have executed and output of all the commands are always be there in the display. So if you want to run a program, you need to scroll down and you have to see your specific output. In order to avoid some kind of ambiguity, it is better to use clear command window. So every time when you run a program as a fresh one, the command window is get erased and only the output of that particular program will get displayed when you use the CLC command. And the next command is clear all. What is the use of this clear all command? This clear all command is used to clear all the variables that are present in the workspace, because previously and more previously and more previously you have executed many programs. Sometimes if you don't clear the workspace, all variables are available in the workspace window. If you want to run a program, sometimes if you have a variable that is present in the workspace, then there are some conflicts. Maybe you have the first program which has A as a matrix, in the second program also you have B as a matrix. Now in the third program you want to create A and B. It may lead to some confusions, or it may lead to some duplication of the values. In order to avoid that, it is better to go for clearance. Clear all the workspace variables that was previously created and make the workspace window empty to proceed with the program. So this is what I have included these two lines in all the programs. So in this program, first what I created, age equal to 20. See, I have assigned the age value as a number to the variable 20. So here age is a scalar and the value 20 is stored like this. So what is the size of this matrix A? 1 cross 1, 1 row 1 column, like that. Next, to come to the second version, here also I have taken age equal to 20, but I have used the if else statement. In the first version if only used, in the second statement if else version is used. So this is the bullet, no need to worry about that when you type the program. This is a bullet, right? So sometimes you may confuse with whether you have to put a dot or not, whether you have to put a dash or not, like that. So these are all bullets in the PowerPoint presentation. So you should straight away write CLC clear all age equal to 20, and if you want to do only with if condition, then you can go for this, and if you want to do if else, then you can go this version, right? So in both the cases age is assigned as a number directly, age equal to 20, likewise it is assigned a number directly. Now my requirement is how to read the age value from the user, how to get the, for different age values I want to display the eligibility. So for which, what is the command used? Age equal to, see this, age equal to input enter the age, age equal to input, then the input enter the age, right? So likewise you can give. So if you are familiar with the C or C++ language, it is equal to scanf in case of C and cout, in case of C++. Likewise this display command is equal to printf in case of C and C++. Here display. Now what is my fourth version is? My fourth version is creating a matrix of ages, right? So here look at it, the age, it is created as a 1, 2, 3. That means A is a 3 cross 3 matrix. For a 3 cross 3 matrix, how to calculate the eligibility? So I need, this is a 3 cross 3, though I have to use two for loops. One for loop is for row, another for loop is for column. The outer for loop is meant to take each row and the inner for loop is meant to take each column. So how this program get executed? So what is the size? A equal to 20, 18, 17, 25, 46, 60, 11, 14, 12. So this is the matrix, right? So the first for I equal to, for I equal to 1 to 3. So that means for I equal to 1, first it is taken, this row is taken. Within the for loop, for j equal to 1 to 3, now j equal to 1. So I equal to j equal to 1, that means this element is taken. And this is compared with the age of I comma j. Now what is age of I comma j? A of 1 comma 1 is greater than 18 or not, it is checked. And it is, after checking it, it is found that it is greater. So y is printed. So eligible, there is an output matrix. In that eligible, what is printed here? In the place of 20, y is printed. Next, what is get incremented? The for loop I value is get, the for loop the j loop is get incremented. The j go to 2. That means this second value. If it is eligible, then y is present. If it is not eligible, that is another thing, 17. After having completed this entire column, it goes to the next row. Likewise, it goes on. Likewise, it goes on next row and the next row. So the first thing, row increment is happened. Within the row increment, you have to increment the column values. You have to increment the column values. And for each value, you have to check the corresponding age, whether it is greater than 18, and accordingly you have to display y or n in the eligible matrix. So finally what I will get? I will get the eligible as a matrix of size. Again, it is, the size is also going to be 3 cross 3. But what are the contents? It will be y, n, y, like that elements. So if you look at this program, all these 4 version is doing the job of eligibility to vote, but version is different. Here this is simple F and this is if else, and here age is input, that is it is getting from the user, and here this age is a matrix. Let me go to the next version. So here also in the 5th version also the same thing, but here data is loaded. Say for example you are going to calculate the eligibility of a vote of particular street. You go to the street, get the age of all the persons, create a .m file. You can also create .txt file or .csv file or .xlx file, whatever it is. Here in this example it is created a .m file. Look at it. If you put a semicolon here, the output is not displayed. If you want to display the output, then this age data, that m file is stored as a matrix to age. Now what is having the age? Age data is also having the age, and age is also having the age. But that age data is a m file and this age is a matrix file. Now using this for loop, because it is a matrix, right? Since it is a data, the data is loaded as a matrix, and this matrix is, since it is a matrix, you need to use two for loops, one for incrementing the row, another one is for incrementing the column, and accordingly you have to create a variable eligible with fills y and yes, y and no. Coming to the 6th version, if you look at it, I have created a function called vote.m, and there is a sub function called compute.m. So here if you could check that, you will see CLC clear all, age data, age and eligible, you are doing it. So this eligible is a variable where which you are calculating the compute statement, and a compute is the subroutine that is called. So from the main function vote.m, you are calling the subroutine. This is the main function and this is the sub function. This is the main function, this is the sub function. So from the main function you are calling the sub function. Let me erase this, and once again I am explaining this. So this is main function. As usual you have CLC statement, clear all statement, load the age data and assign the age data to the matrix. Now you are calling a sub function compute which holds this parameter as an argument, and this age is passed. So if you call this age is passed to ag and the compute is called here, right? Now after having performed all this computation, the result is written to this eligible, and eligible is get displayed. So this is the statement for writing a subroutine. So when you want to write a subroutine in MATLAB, the syntax is you have to use the keyword function, then within square bracket you have to write the return variable name, then as usual function name and passing arguments. So the compute is a subroutine which accepts the arguments, and that argument is used inside the program. Now this ag is assigned to a, right? Then this a is used throughout the logics, then it is returned to function. If you got right there. So here you have to write two m files. One m file is vote and another one m file is compute.m. Remember, the file name as well as the function name both should be same, right? Remember, the file name as well as the subroutine both should be same. So here in this function you have three m files. One is data m file, another one is vote m file, another one is compute m file. So this is the way you should write simple MATLAB programs. So matrix manipulation, loading the data, and usage of if conditional statement as well as usage of loop statement, for loop statement. If you are very familiar with all these constructs, definitely you will be a master in MATLAB, because here always we are going to access the elements. How to access the row element and how to access the column element, and how to do the computation and how to insert a particular row or a particular column, that gives you a simple scenario for calculation of all the stuff. So in the next presentation, followed by this presentation, a short presentation, I will give you an idea about how to plot graphs using MATLAB. Thank you.